this receiver and transmitter. Okay, this is a UART. What is meant by UART? UART is nothing but a serial communication protocol. So if you want to, in an embedded system, we have discussed that there will be n number of modules, right? There will be not just a single module, there will be n number of modules. And if any of the two modules are willing to have the transaction of information or the data among those two modules, then it may make use of this protocol. Okay, see, each and every theory concept is very important. Then only you will be able to understand the program. Okay, the program I will be explaining in the last 5 to 10 minutes. That's all. And if you want to understand that program, all these concepts are very much essential. Okay, so what is meant by UART? UART is nothing but a protocol. Okay, protocol means what? It is a set of the rules that it has that it has to be followed in order to have the transaction of the data between the two modules that is existing in the embedded system, right? I repeat once again, UART means a protocol, okay, a serial communication protocol. So in order to have the transaction of a data among the modules which is existing in the embedded system, it has to make use of this protocol. Okay, the abbreviation of UART is Universal Asynchronous Receiver and Transmitter. Okay, so it is an onboard communication interface protocol which allows the embedded system to have an onboard communication. Okay, in order to establish the communication within a board, it has to make use of some protocol, and it is making use of this UART protocol. Okay, why it is called as an asynchronous? So you know what is meant by synchronous and asynchronous, right? So synchronous means all the modules will be working on a global clock, so that is called as a synchronous. And asynchronous means there will be no a particular or a predefined clock rate for all the modules that is present in an embedded system. Okay, so I mean to say why it is called as an asynchronous, because the sender whatever you are assuming and the transmitter whatever the receiver whatever you are assuming, both the transmitter and the receiver will not be working on a same clock rate. Okay, it will not be having the same clock cycle, it will be running on a different clock cycle. Okay, so that's why it is called as an asynchronous. Jeevan, are you recording this one? Jeevan?
Yes, sir.
Jeevan present?
Yes, sir.
Not present. Yes. Okay, fine. So UART is a serial communication protocol in which a data is transferred serially bit by bit in a time. So as the name as the UART is called as a serial communication protocol, so as the name specifies, it will be transferring the bit. It will be transferring the bits in a serial manner, that is bit by bit. Okay, all the bits will not be transferred at a time. So all the bits will be transferred in the parallel communication protocol. But since we are considering the serial communication, the data is being sent from the transmitter to the receiver bit by bit. Okay, so asynchronous serial communication is widely used for the byte-oriented transmission. Okay, so if you just look into the figure there, so there are two modules, and both the modules are making use of the UART protocol, and there is having the bidirectional communication. That is, so there is a transmitter and the receiver in the module 1, and you can also observe the transmitter and the receiver in the module 2 also. So whenever the module 1 is transmitting the data, the module 2 is receiving the data because there is a receiver, and again whenever the module 2 is transmitting the data, the module 1 is receiving the data because it is having the receiver at that module 1 also. Okay, so this is the basic construction whatever I've explained there. I hope you have just got an idea what is meant by UART, right? Okay. Okay, we'll go to the frame structure. The frame from here it is very important, because based on this registers and the structures only you will be writing the program. Okay, please make a list or make a rough note, whatever I am trying to tell, please write it in your notes so that it will be helpful whenever I am writing, whenever I am explaining the program. Okay, the frame structure includes three fields. So the first field is a start bit, and the last field is a stop bit. So why you have to use the start bit and stop bit? So it is something, I'll just give a simple example. So I think you have seen a walkie-talkie, right? It will be generally holded by the police people, right? So these people, how they will be talking? They will be speaking some sentences, and last they will be telling it as over, right? They will first speak out some sentence and they will be telling it as over. So over means what? So he has completed whatever he wants to tell. He has completed telling. He has completed whatever he wants to tell, and he's just notifying to other person that others can speak, right? So over means what? So over is acting as a stop bit. So similarly, so this UART has a two fields, that is a start bit and stop bit. So along with the over at the start during sending of the information, you are notifying with a start bit, and at the end of the data bit, at the end of the data byte, you are also notifying with a stop bit. Okay, so this start bit and the stop bit, why you are sending is it will be notifying the receiver. So from where the data byte, or from where the actual data starts and from where the actual data ends. Okay, start bit and stop bit is very important in the UART concept. So start bit is a bit which indicates that the serial communication has started and is always low. So remember, the start bit is always low. Okay, all these things are very very important. We will be asking the Viva questions at the last. It may be in the form of a quiz. So please try to understand all these concepts. Okay, it is a bit with which indicates that serial communication has started. Okay, the start bit. Uh, Whenever the receiver gets this start bits, the receiver should be in a position to understand that there is a starting of serial communication. Okay, and the start bit will be always low. Okay, the data bit packet. So the data bits can be a packets of 5 to 8. It is not 9. Sorry, you make a necessary change there. So in the record, you have to write it as 5 to 8 bits. So the data bits can be a packets of 5 to 8. Okay, you cannot transmit a 1 bit or 2 bits. You have to transmit a byte which is having at least 5 bits. Okay, so you can your data can be, or your length of the data can be between 5 to 8 bits. Okay, normally we use a 8-bit data packet which is always sent after the start bit. So in this program, that whatever we are trying to send, or usually will not send a 5 or 6 bits. Usually we'll be sending the 8 bits, and the 8 bits whatever you are trying to send now, that will start after the start bit. Okay, the stop bits. So this is usually 1 or 2 bits in length. So this stop bit can be either a 1 bit or can either be a 2 bits. Okay, this can also be the Viva question. Okay, it is usually 1 or 2 bits. So it is a set after, it is sent after the data bits packet to indicate the end of the frame. So why you have to send this stop bits is you have to notify the receiver that this is the end of the data bit. This is the end of the data that you have sent. So the stop bit will be always high. Remember, the start bit is always low and the stop bit is always high. So if you just see the data frame structure there, so first is start bit, and the start bit is what? Low. If you can see, the start bit I have written in low, and I have written the 8 bits there. Okay, I am considering the byte data, so I am considering the 8 bits. So in the 8 bit, after the 8 bits, you are passing only one stop bit. We are not considering the two stop bits. We are just considering only one stop bit. Okay, the stop bit can be either 1 or 2, right? But in our example, we are considering only one stop bit. So is it clear till here? Any doubts? Any doubts with respect to these things? Shall I? Is everyone listening?
Yes, sir.
Shall I go to the next slide? I'm asking. Is it clear till here,
Yes,
students?
sir.
Okay, fine. Next is LPC2148. So this is the processor that you are using, right? So this processor will be supporting the two UART protocols. Okay. So there are two UART protocols, that is UART 0, namely it is UART 0 and it is UART 1. So we can connect the two UART enabled devices. So since there are two UART modules in the LPC2148, you will that LPC2148 will be supporting the two modules to connect. So what are all the two modules you can connect it for the LPC2148? You can either connect a GSM module, GPS module, Bluetooth module, etc. So these are the examples I have given. You can connect any of the modules for the LPC2148. So how many modules it will be supporting? The two modules it will be supporting, because it has a two UARTs, that is UART 0 and UART 1. Okay, UART 0 and UART 1 are identical, other than the fact that UART 1 has a modem interface included. So UART 0 and the UART 1 both are identical, but there is only one difference, that is the U1 has a modem interface. Okay, so if there is a modem interface, it will be supporting the UART1 will be supporting the modems to connect. So modem is nothing but the modulator and demodulator, and that is not our concern to understand what is modems, what is UART, all those things. But our concern is how to display the message. Okay, whenever I come to the program, then you will understand what is the objective of the program. So right now, so there are UART 0 and UART 1. Anyway, we are not using UART 1, we are using UART 0 only in our program. Okay, so since we are using UART 0, we shall understand what are all the registers that we will be using in order to write the program, and what are all the registers that are resided in UART 0. So the two pins that what we are discussing right now is TXD0 and RXD0. So that 0 represents, it is with respect to UART 0. If it is 1 means, if it is TXD1 and RXD1 means, it is with respect to UART 1. Okay, so what is the TXD and RXD? So that is nothing but the pin. Okay, the pin of UART 0. TXD is nothing but the transmitter, and the RXD means the receiver pin. Okay, so serial transmit data pin and serial receive data pin. So it should have, as we have seen in this diagram, it should have two pins, that is a transmitter pin as well as a receiver pin. Okay, coming back to this, coming back to the next register, UART 0 line control register, that is U0 LCR. Remember, we are all discussing the registers with respect to UART 0 itself. Okay, so it is an 8 read write register. So whatever the register that we are considering, right, that is a 8-bit, and you can read the data, and you can also write the data into the U0 LCR. So LCR means what? Line control register. So it determines the format of the data character that is to be transmitted or received. Okay, it determines the format of the data character that it is to be. So this register, what it will do, it will determines the format of the data character that it has to be transmitted. Okay, so there are 8 bits, so 0 1 2 3 4 5 6 7. From 0 to 7 it is 8 bits are there, but anyway we are not using all the bits, we are just discussing about the bits that whatever I have taken. That is, we are discussing about 0 1 and 2 and also 7. So 0 1, it is a one field. 0 and 1, it is a one field, we are not dividing 0 bit and the 1 bit. 0 and 1 is a completely a one field. Okay, it always specifies what is the length of the word that you are transmitting from the one module to another module, whether you are transmitting the 5-bit data, or whether you are transmitting the 6-bit data, or you are transmitting 7, or you are transmitting 8. So it will be stating, so what the length of the data that you are transmitting. So 0 1, it can take how many bits? This field will can take 2 bits. So that's what I have written in the table there below, you can see here. So 0 0, if you are writing 0 0 in the first field, it means that you are sending the data whose length is 5. If you are loading 0 1 into that field, it means that you are loading 6, you are transmitting the 6-bit character length. 1 0 means 7-bit and 1 1 means 8-bit. So right now in our example, we shall consider that we are moving the 8-bit data. Okay, we are moving the 8-bit data. So what I have to load in the first field, if I am considering that my data is of 8-bit, what I have to load it into the first field I am asking?
1 1
1. Correct. Okay, so the bit 2, so the number of stop bits. So the bit 2 will tell you how many number of stop bits you are using. So the stop bits can take either 1 or it can take 2. But in our example, we are considering that the stop bit can be, we shall consider that the stop bit is only 1. So therefore I have to load it as 0 into the second bit. Okay, so 1 1 into the first field and 0 into the second field, I mean the second bit. Next we have to discuss about a DLAB also, that is a DLAB. Okay, that is a 7th bit, that is the last bit, and we are not discussing about the 6543. So you know what is meant by parity and all, but anyway we are not discussing all those things now. We shall just discuss whatever it is required for the program. Okay, so DLAB, we should also work on the DLAB, that is DLAB, that is a 7th bit. So this is very very important, try to understand the concept properly. So what is the 7th bit called as? DLAB, right? So the abbreviation of a DLAB is a divisor latch access bit. Okay, divisor latch access bit. So why you have to use this particular bit is in order to access some of the registers. So why you have to access that registers, I will tell in the next slide. So if you want to access some of the registers or latches then you have to use this DLAB register. So if you are making this DLAB as 0, you are disabling the you are disable you cannot access to the device latches registers. So if you are making it as 1, if you are making it as 1, you can access some of the divisor registers. Okay, we shall see what are all those registers and what is the use of it. Okay, so use U0 LCR. So U0 LCR will be what right now? U0 LCR, the register whatever we have discussed in the previous slide. So it will be what? So 1 000 0011. So what is that? Why you have to load 10000011? Because I told that you are using only the 7th bit, 2nd bit and the first field. So in the first field you need to write 11, and in the next field you need to write 0 because you are using only one stop bit, and again in the DLAB you have to write what? 1. So if you are loading that, you will be getting as 83 in the hexadecimal in the LCR. Is it clear till here? Everyone understood till here? Have you got 83 understood? Because you need to pass 83 in the program. Okay, you need to pass this 83 value in the program. At that time you shouldn't get the doubt why 83 is passed. Is it clear? I'm asking.
Yes, sir.
Is it clear, students?
Yes, sir.
Yes.
Yes?
Yes, sir.
I'm not able to hear any voice. Is it clear?
Yes, sir.
Okay. Okay. So I hope you understood why 83 has to be passed there. Then DLAB. What is the essence of this DLAB? So if you want to access any of the latches, then you have to enable this DLAB. So therefore, how you have to enable this? By providing it as 1 there. And if you want to disable, you have to write it as 0. So always, so I will tell what is the use of this DLAB and why you have to access some of the registers. So you know that the CPU, whatever you are using, it will be working in a very faster way when compared to the peripherals that it is being connected to your CPU. Okay, I mean to say that the clock rate or the clock that what the CPU is using is running at a very high rate, and whatever the peripherals that you are connecting, right? So those peripherals will be having a very low clock rate, and in order to match these two clock rates, you need to access some of the registers. So if you want to access some of the registers, then you have to make the DLAB as 1. Okay, so now we shall see what are all the registers that you need to access. So you need to access the 2 registers, and the name of these 2 registers is U0DLL and U0DLM. So U0 means with respect to UART 0, DLL means a divisor latch least significant bit, DLM means a divisor latch most significant bit. So L refers to the DLL, in the last L refers to LSB and M refers to MSB. Okay, so these are the 8-bit read write register. So that whatever the 2 register just now I told, right, that is U0 DLL and U0 DLM, these are the 2 8-bit registers. It is both read and write, either you can write or you can read, both is possible from this registers. And divisor latch access bit, so DLAB is U0 LCR must be 1 in order to access this divisor register. So that's what I told. So if you want to access, okay, if you want to access this U0 DLL and U0 DLM, you need to make DLAB as 1. Okay, am I clear? So if you are making DLAB is equals to 0, you will not be able to access these 2 registers. If you are not able to access these 2 registers, then whatever the peripherals that you are connecting to the CPU will work in a different clock rate, and CPU will work in a different clock rate, and there will be no compatibility between the 2 devices. So in order to have a compatibility, or in order to create a compatibility between these 2 devices, it is very much essential in order to access these registers. Okay, to access U0 DLM and U0 DLL, DLAB should be equal to 1. So that's what I have written again at the last sentence. And U0 DLM is equals to 8-bit. First you have to write that, and U0 DLL you have to write next, because that is LSB. DLM is MSB and DLL is LSB. So totally 8 plus 8, how much? It is 16-bit register completely. If you are adding these 2 things, then it will be a 16-bit data. Okay, now we shall understand what data you need to pass it into these two registers in order to make the devices to have a compatibility. I repeat once again, what now we are trying to understand what data you need to pass into these two registers in order to make the two devices to have the compatibility. Okay, because the peripheral will be having a different clock rate and the CPU will be having a different clock rate. So therefore you need to make a compatibility between these devices in order to have the effective communication. Okay, am I clear till here? Shall I go to the
Yes,
next
sir.
slide,
Yes, sir.
or do you want me to repeat it again? Shall I go to next slide?
Yes, sir.
Please, I
Yes,
want the
sir.
answer.
Yes, sir.
Otherwise, there is no point of going to the next concept. Without this, without understanding this concept, there is no point to go to the next concept. Is it clear?
Yes,
Yes,
sir.
sir.
Okay. So as I have told, there is a simple formula here, that is U0 DLN plus U0 DLL is equals to P clock divided by desired baud rate into 16. Okay. So P clock means what? P clock is nothing but the peripheral clock. Okay. P clock is nothing but what? Peripheral clock frequency. And you need to make a compatibility between the CPU clock as well as the peripheral clock. So for that you are using this formula. Now you are interested what you have to load it into this U0 DLM and U0 DLL. Okay, and the desired baud rate means what? Baud rate is nothing but the number of bits that are being transferred from one module to another module within 1 second. Very important definition. What is meant by baud rate? Baud rate is nothing but the number of bits that are being transmitted from one module to another module within 1 second. That is called as a baud rate. Okay, into 16. Okay, into 16. Why you have to write into 16? Because U0 DLM plus U0 DLL, 8 plus 8 is equals to 16. So that's why you have to multiply it with 16 only. Okay, so that a CPU clock frequency, that whatever we are considering, right, that clock frequency is equals to 12 megahertz, and the peripheral clock frequency will be usually clock frequency divided by 4. Okay, the peripheral clock frequency will be 4 times lesser than the CPU. This we are assuming it. Okay, not assumption, almost all the peripheral devices will be running at a clock rate which is 4 times lesser than the CPU clock rate. So that's why we are dividing the CLK, that is a CPU clock divided by 4, that is 12 megahertz divided by 4, that is equal to 3 megahertz. So this is the clock frequency that we are assuming. So this is the clock frequency that the peripheral device, that whatever you are connected, that is working in. Okay, so the desired baud rate will be what now? So if you so the desired baud rate is equal to 9600 bps. Bps means bits per second. You are trying to send 9600 bits per second. So this is the desired baud rate. So if you substitute all these values in the above formula, then you will be able to get the value as 19.5. And therefore we cannot, since we cannot represent this 19.5 in the hexadecimal, we are approximating it to the 19 value. So the 19 value in the hexadecimal is written as 13. So therefore you need to pass 00 in DLM and 13 into DLL, because 00 is a MSB and 13 is a LSB. So totally you need to pass 0x0013. So why only 4 digits you are using in this hexadecimal? Because it is only 16-bit length. Right, we are not considering the 32-bit register. The registers whatever we are discussing is only about 8 plus 8, that is 16 bit. So therefore you have to write 0x0013. So 00 you have to load it in DLM and 13 you have to load it in DLL. Is it clear till here?
Yes,
Yes, sir.
Okay, next register is, so in case if the session gets over, I think the session will get over at 12:30. I think the session will get over at 12:30. If I am not able to come within 12:30, then I request all of you to log in again. Okay, it may take for 10 to 15 minutes more. Please do relog in again and try to understand the program completely in today's class. U0THR. Okay, we are discussing about the register, that is U0. I request the students who have kept the phone in mute. Namrata, I think. Namrata, you please mute your device. Okay, U0THR. So the abbreviation of U0THR is UART 0 transmit holding register. Transmit holding register. So see, just remember all the registers, okay, because we are using all these registers in your program. So it is an 8-bit write only register. So this register you cannot read the data, you have to write the data. So transmit holding register means, so whatever the data that you are interested to transmit from one module to another module, that data you need to store it in, or that data you have to write it into this register, that is U0THR. THR means a transmit holding register. So whatever the, I repeat once again, whatever the data you are interested to transmit from one module to another module, that data you need to write it into this register, that is U0THR. Okay, it is an 8-bit and it is only read. So it is only write only register. So the data to be transmitted is written into this register, and in order to access this very important concept, so if you want to access this U0THR, you have to make a DLAB is equals to 0. So when you have to make DLAB is equals to 1, so you have to make DLAB is equals to 1 if you want to access the previous two registers, that is U0DLL and U0DLM. So if you want to access this register, again you need to make a your DLAB of U0LCR equals to 0. Okay, DLAB will come in which register? U0LCR, right? The first register, that whatever we have discussed, you have to make that DLAB is equals to 0 in order to access this. Okay, so the length of the data is only 8 bits, so that's what I have shown, but it starts from 0 to 7, and the U0LCR is equals to 11 now. So I'm sorry, not it's 11, it is 000000011. You are not making the 7th bit as 1. See, I'll just go back. See here, if you can see here, you have made it as 1, right? The last bit you have made it as 1, so that's why it has become 83. Why you have made it as 1? If you are making that as 1, then only you will be able to access the U0DLM and U0DLL. But after using this U0DLL and U0DLM, okay, you have to make the DLAB is equals to 0 in order to access this one. So that's why the 7th bit is made as 0 now. So once you are making the 7th bit as 0, you are getting the answer as 0x03. It is not 83, it is 03. 83 was in the previous case. Now it is 03. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Okay. So U0LSR. Next register now what we are discussing is U0LSR. So it means that UART 0 line status register. Okay. So why we have to study this register is we should get to know the status. So once you have transmitted the data onto this THR register, okay, you should get to know whether the data has been transmitted to the module that whatever you are expecting or not. You have to get an acknowledgement, or you need to get the status. So for this purpose you are using this LSR, that is a line status register. Okay, to check whether the data is reached to the other device or not, this register is used. Okay, so very clearly I have written all the statements. Even if you have any confusion, just go through this PDF. Okay, to check whether the data is reached to the another device, you need to use this register, and it is a 8-bit read only. You cannot write this because it is only a output register. It just says the status, whether the data has been reached or not. It just says the status. You cannot write anything into it. Okay, so use the 5th bit to check whether the data transfer is done. Okay, so I told that it is a 8-bit, right? We are not bothering about the 7th, 6th, 4th, 3rd, 2nd, 1st and 0. We are just bothered about the 5th bit. So 5th bit says whether the data that whatever you have transmitted by making use of that THR, by making use of that THR is transmitted or not. Okay, just says the status. So if the 5th bit is 0, the valid data has been sent. It means that the valid data has been sent. If the 5th bit is 1, means it is empty. Okay, which is empty? The U0THR is empty, and there is no data returned into the transmit register, and therefore there is no data transmitted to the other device. Okay, so this register will just tell you the status, and which bit you need to check. Only the 5th bit you need to check, and all other bits you are not bothered about it. Okay, is it clear? So what are all the registers we have studied till now? We have studied U0LCR. I request all of you to write down very fastly. We have discussed about U0LCR, right? In that we are bothered about only the DLAB and the word length, and also the bit related to the stop bit. Okay, and again we have discussed about U0 DLM and U0 DLL, and again we have discussed about U0 THR, and we have discussed U0 LSR. Okay, these many registers we are using in a program. Okay, you shouldn't. Okay, okay, coming to the program, I request everyone to relog in once again because only 4 minutes is left out. I'll just end the session now, and I request all of you to relog in once again. Okay, will you do that? I just take 10 minutes time to complete this. Yes, relog in once again.
Okay, sir.
Session now. Okay.
Yes, sir.
This is what.
No.
Right. The program is the objective is write an embedded C program to display the hello world message using the LPC2148 internal UART. So the LPC2148 kit, that whatever you are using, no, it is having the two protocols, that is UART 0 and UART 1. So by making use of this UART 0, you try to send the message hello world, and you receive that you receive the same hello message, that whatever it is sent from the CPU, and you display that hello word on the monitor. So this is the objective. Okay, you are writing the program in order to send the message hello world, and you are dumping the program. I mean to say, you are transmitting the hello world message. You are transmitting, and you are sending the message to the display world now. So sorry, display device now. Okay, so the message is what? Hello world. So hash include lpc214x.h. Okay, so this program you can use this for any of the version, that is from LPC 214.8 to 214.6.7, or some versions are there. So therefore I have written it as x. Okay, so hash include lpc214x.h, void uart underscore init void. So this is a protocol. You are trying to tell for the compiler that you are returning it from the function without any value. Since you are writing void into that bracket, you are trying to tell for the compiler that you are returning from the function without any values. Okay, unsigned int delay, you are using the delay, and again you are using the pointer, and again you are also displaying the message as hello world, and therefore the hello word is declared under the array name. Okay, hello, and at the last I have written the /n. It means that, what does it mean? New line, right? It is a new line. After printing this message, you have to print again the same message in the next line. So this program, whatever I'm explaining, no, this program will be keep on displaying the hello world for infinite number of times. Okay, there is no stop. We are trying to display this message on the display device for infinite number of times, and that too you are not displaying hello world continuously. In one line you are displaying the hello world, and in the next line you are displaying the hello world, and in the next line. So I mean to say that you are displaying the message in a line wise. Okay, you're not displaying the message in a same line for so many times. You are displaying the message in line by line wise. Okay, so coming to the logic of the program. So let me start with the logic. So while one, you are writing the while one here. Directly you are making the controller to enter into the loop without any condition, and you are calling the program, that is you are calling the function, that is uart underscore init. So whenever you are calling this program, the processor will start executing from this line. So this is the function. So pin select 0x00005. So why you have to pass 5 here? Can anyone explain about pin select register? So pin select register is used for what? In order to make all the pins to work under. Can anyone tell that name? In order to make all the pins to work under?
General purpose input output.
Yes, very correct. In all the programs, that is the two programs that are not only in the two programs, in all the rest of the programs, you will be making the pins to work in the general purpose input output, but only in this program. Okay, but only in this program you are making the pins to work as a transmitter and receiver. If you just recall the first theory class related to the part B, there are 4 functions. you can make the pins to work as a 4 functions, right? You can make it to work as an input output device, or you can make it to work as a transmitter or receiver, or you can also make it to work as a what is that, interrupt, I think, right? Interrupt. So the I think one more is what, PLL. Okay, there are 4 functions. There are PLL only, no? PWM. Pulse width modulation. Yes, pulse width modulation. So you can make the port pins to work in either of these functions, but on all the programs we are making to work as a input output, but only in this program we are making to work as a transmitter, and you have to make it as a receiver. So I have just elaborated the pin select 0 there. All are zeros, only the last field, that is 5, I have written as 0101. So 01, the first this one, this 01 will make P0.0 to work as a transmitter, and this one will make it as a receiver. Okay, so you are not passing 10 there, you are passing 1. If one of the pin is working as a transmitter, means obviously it will make another pin to work as a receiver. Okay, so that's why you are passing 0101 here instead of passing 00. Okay, in all other programs you are making to work as input output. Only in this program you are making to work as transmitter and receiver, because we are dealing with a communication protocol. You have to make one port as a transmitter and one port as a receiver. You have also seen the construction figure in the starting slide itself. In both the modules you can see transmitter and receiver. So that's why we are making it to work as port 0.0 as transmitter and port 0.1 as receiver. Is it clear about this?
Yes, sir.
Okay. U0 CLR is equal U0 LCR is equal to 83. I hope you know why you have to pass 83. So 83 states DLAB is equals to 1, and again you are making the word length is equals to 11, and also you are making the second bit, that is a stop bit, you are making it as 0. So therefore you will be getting as 10000011. That is nothing but 83. This explanation I have already given in the previous slide itself. I hope you know what is 83, right?
Yes.
Okay, and then you have to make DLM and DLL as equals to 00 and 13. This explanation is also given in the previous slides. Okay, now after using this DLM and DLL, again you have to make this LCR is equals to 3. Why? Because why you have to make from 83 to 3? Can anyone answer why you have to make LCR is equals to 3 from 83? Why you have to make that? Why you have to make it as 3 instead of 83? I've explained, right? See here, I am making it as a 3 here because DLAB should be equal to 0 in order to access this THR register. So if you want to access this THR register, the DLAB should be made as equal to 0. Okay, so initially first I have made DLAB is equals to 1. Then I have made utilized of DLM and DLL. After making use of a DLM and DLL, again I am making DLAB is equals to 0. If I am making DLAB is equals to 0, then LCR will become what? 3. LCR will become 3 from 83. Okay, that's why first I have passed 83, then I have made use of DLM and DLL, then I am making it as 3. Is it clear? Is this function clear for you? Shall I go to the main program? Yes or no?
Yes, sir.
Okay. So after calling the function, it will modify all the registers. Okay, whatever the registers that you have written, no, all those registers will be modified there. Okay. Then after coming back from the function, it will start executing from this line, that is PTR is equals to array. It means that H will be loaded into PTR. Okay, H, you have to display the message as hello world, right? So H will be loaded into PTR, and you are comparing the PTR with the null character. So where the null character will come in your string, the null character will come only at the end of the string, right? So it will be taking the data, it will be comparing until you enter into the null character. But it means that until you reach the last letter, it will be keep on comparing. So first H is compared with a null character, H is not equal to null character, so therefore it will enter here, and that H will be loaded into THR. So you need to transmit H only, no? So therefore that H is loaded into THR. THR means what? Transmit holding register. So this register will be holding H right now. Now this is very important. So while U0 LSR is ANDed with 0x20, why you have to AND with 0x20? If you elaborate 0x20, what is the binary representation of 20? 0 0 1 0 0 0 0 0. It means what? You are checking which bit. What is LSR and why you have tried to enter what?
Fifth bit we are checking.
You have to check the fifth bit. Yes, you have to check the fifth bit, and if the fifth bit is having 0 means what? If it is having 0 means the valid data is there. If it is having 1 means the data in the THR is empty. So you need to check whether the data is present in THR or not. So it is just a you are just trying to check the status, okay, by making use of this while condition. And again, after transmitting the H, you are giving a very small delay. You can see the for loop there. For delay is equals to 0, delay is less than 600. You are just giving a very small delay, and again you are going back and you are taking he. H is over, H is already transmitted, and you are taking E. That is a second letter from the sentence. Okay, and again you are repeating the same process, and once the complete sentence is done, and once it reaches to the null character, so it will come out of the loop, and again there will be a small delay. Again there will be a small delay, that is 60,000. Small delay means reasonable delay you are giving. Again you are displaying the hello character, hello world in the next line. Okay, this keeps on repeating, it will never ends. That's why this program is written for to display the hello world message in the display device for the infinite number of times. Is the concept clear for everyone? Is anyone? Okay, thank you for attending the session. If you have any doubts, please don't bahat the programs. Okay, you cannot bahat all these numbers. What is 83? All these numbers you cannot bahat. Okay, I'll just give an instructions how to face the lab internals. So it will be exactly as a first online assessment. However you have taken now, the same way we will be conducting the lab internals also. But whenever we are instead of sharing the question paper, we will be sharing what programs you need to write. We will